Hey everyone, today's lesson is going to focus on trigonometry a little more in depth with the kind of circular nature that sine and cosine and tangent are now beginning to take on. So what we're going to do is we're going to look at it in the xy plane. So normally your xy plane, this is what I'm referring to, and when we talk about trigonometry, we're just looking at, what's sine, cosine, and tangent going to do in the xy plane. Okay, so one thing we also want to keep in mind is the way that we state our coordinates, x comma y. And for example, we have a point P that is -5 comma 12. So it's -5 in the x, 12 in the y, and we want to give the ratios for sine, cosine, and tangent. And also, we're going to take a look at the angles. So what we want to keep in mind is the x and y plane. Usually this makes a lot of sense, but when I'm working a lot with trigonometry, I'll often draw this and just the positives and negatives of x and y. So x is positive here and negative there, and vice versa for y. So if we look at -5 comma 12, we should understand that this is going -5 in the x direction and up 12 in the y direction. So we could say that that is roughly around here. And so this is our point. And so we can now start to draw that, okay, we have a standard angle measured from 0 degrees there, and we have a reference angle here. Alright, so just kind of with that drawing, we get a lot of information. I want to look at just giving the ratios for sine, cosine, and tangent first, however. And so you can kind of see that when we draw this point, it looks like there's kind of like a very subtle implied right angle triangle right here that's formed between the terminal arm, how much you've gone up in the y direction, and how much you've gone over in the x direction. So I'm going to redraw that right angle triangle. Knowing that I've gone over -5 and up +12, and then this would represent my reference angle. So that being said, I want to give the ratios. At this point, I would be able to give the ratio for tan, so maybe I can just do that right away. Tangent of the angle is equal to 12 over -5. So that's one of those ratios down. For the other two, I need the hypotenuse, so we're going to go ahead and say our a squared plus b squared is equal to the hypotenuse squared, or c squared. Okay. So that -5 squared is +25, plus 12 squared, that's plus 144. Add those together, c squared is 169. So c is equal to the square root of 169. So that's 13. Okay, so that represents this length here. Also note that the square root of 169 is plus or minus 13, but we don't quite include the negative, especially for the hypotenuse, because it is meaningless to say that the hypotenuse has a negative length. It will always have a positive length, so can immediately scratch the negative answer out of our solution. So now that I've solved for the hypotenuse, I can give the other two ratios. So the sine of the angle is going to be 12 over 13, and the cosine of the angle is going to be equal to negative 5 over 13. Okay, so in terms of just giving the ratios for the basic trig functions, those are those ratios. So that's kind of, I'll say that we've completed that. Now we're going to look at the angles here. And this is kind of a thing that isn't always asked, but I find that it can give a lot of insight to what's really going on here. And so what I want to do is kind of treat these, what if we were solving for the angle here? And what would we get for an answer? So let's just do the sine first, because that's the first one we have. The inverse sine of 12 over 13. And that gives us an angle of 67.38 degrees. I'm just going to round to 2 digits. That's just makes things easy. Okay, so 67.38 degrees. I just want to leave that. I want to solve for every angle, and then we're going to come back and just kind of look at what those angles represent. Okay, so inverse cosine of negative 5 over 13. That gives me an angle of 112.62 degrees. We'll do the inverse tan of 12 divided by negative 5, and that gives me negative 67.38 degrees. Okay, so now that I've gone ahead and done all of that, if we kind of look at these angles, what can we relate here? What can we say about this? Well, the inverse sine and the inverse tan happen to give the same angle, but tangent was negative and sine was positive. We'll also look at this as giving the reference angle. So when we look at 12 over 13, that's going to give us our reference angle. The inverse cosine, however, seems to have given us our standard angle. So often when working with these triangles or in a full 0 to 360 degree plane, I often look at these angles, and that helps my interpretation of the question involved. Okay, now let's also take a look, which is if we set this up like so every time, and we always kind of look at this as drawing our triangle. We go x first, and then we go y. So we go over, then we go up. Or we always have our reference angle from the x-axis as it's defined. Just by comparison, like how you would not do that would be if you went up 12 and then over 5. You'd end up on the same point, but now your triangle is fundamentally different. You'd have to then consciously make the effort to draw that as your reference angle, or this here due to the Z rule. So I always just say go over first, then up, or do your X, then your Y, and so then you can always make the claim that the X coordinate is always related to the cosine of the angle, and the Y coordinate is always related to the sine of the angle. This will always be the case. And then you can also make the jump that now there happens to be places where sine and cosine is positive and negative. So cosine is always going to be positive over here, and sine will always be positive in this quadrant and in this quadrant. Sine will always be negative in this quadrant and that quadrant. So sometimes it's also helpful to label your quadrants. And then we can also make the notion that, maybe we'll do this down here, cosine of the angle is greater than 0. It's positive in quadrants 1 and 4. 1 and 4. So here is where cosine is positive, because if you ever end up with the terminal arm in either one of these quadrants, you're going to have gone over to the right positively. Okay, so then cosine is also negative in quadrants 2 and 3. We'll make the same statements for sine. Often you'll just see me leave out the angle because it's less writing. So sine is greater than 0 in quadrants 1 and 2. Sine is less than 0 in 3 and 4. Okay, so that being said, we're going to look at the next question. And we want to examine the trig ratios for a standard angle of 225 degrees. So, we'll also note that for this, our radius or our hypotenuse length is 1. This will kind of make things easier. I'll show you why it's easier for one example, and then we'll just kind of jump from there. So, cosine of 225, we want to look at that ratio. We want to look at sine 225. We want to look at tangent of 225. Okay, so our standard angle is 225 degrees. That means that our reference angle is equal to 45 degrees. If you kind of recall, we have kind of some basics that we should have written down or ingrained. So for me, it's just kind of memorized. And sine and cosine of 45 are the same, and it's root 2 over 2. And then tangent 45 is equal to just 1. So those are our reference angles, however. We now have to take those ratios and apply them to our new angle of 225 degrees. And we just have to keep in mind where is cosine positive and negative, and same for sine. And then we'll go from there. So cosine of 225 is going to be negative because we've gone over to the left. So it will then be negative root 2 over 2. Sine, after we've gone over to the left, we'll go down, and so therefore sine is also negative root 2 over 2. Now tangent can be thought of as sine divided by cosine. So you have negative root 2 over 2 divided by negative root 2 over 2. And you have the same thing divided by itself, so you get positive 1, which also matches up with our reference angle here. And sometimes it will match up exactly the same, and sometimes it will just be a positive or negative version of this. So what we'll also do is we always want to check our answer. Cosine of 225 is this negative 0.707, and then this also happens to be our negative root 2 over 2. So that kind of tells us that we're correct. That's our ratio. And I want to explain very briefly, if we actually draw that triangle, and we have that this angle is 45 degrees and this is 1. Okay, so what we want to maybe then do is take a look at our regular equation here, the cosine of 45 is equal to adjacent over hypotenuse. You can imagine doing this for both cosine and sine, as well as tangent, and just seeing that if the hypotenuse is 1, our cosine of 45 gets multiplied by 1, and so it's just cosine of 45 will be equal to the adjacent. So that's why I don't really have to worry about the hypotenuse or even this relationship, because it just boils down to the idea that cosine 45 is equal to the adjacent. Now, this is your adjacent. We also sometimes just call that how much you've moved in the x direction. So in some sense, if you set the hypotenuse to be equal to 1, you can always therefore say that cosine is x and the sine is y. So I hope that makes sense. We'll do a couple more questions. So for example, 2. If our cosine of the angle is negative 3 over 5, what is the sine of the angle? This can be a point of confusion for a lot of students. We can always get the answer, but we want to do this as efficiently as possible, and we really want to understand what's being asked here. So if I give you that the cosine of the angle is negative 3 over 5, okay, what is the sine of the angle? I'm not at any point here asking for what the angle actually is. I just want you to give me what the ratio for the sine is. So a different way of doing this is, okay, let's draw this triangle. I go over negative 3, but I don't go down 5. So in fact, I kind of have a hypotenuse length of 5, if that makes sense. Yeah, I have a hypotenuse length of 5. But how do I know if the hypotenuse goes this way or that way? And so I'll just leave that question because that's something I have to actually know. And what I'll find is I know I have a hypotenuse length of 5. So I'll therefore use this Pythagorean theorem here. And that'll shed some insight on things. So I know that this is 5 squared. And we'll say b squared is what I'm solving for, plus negative 3 squared. Okay, so negative 3 squared is 9, plus b squared is equal to 25. 25 minus 9. So b squared is 16. So if I square root the b squared, you get the square root of 16, which is 4. Okay, so what does that represent? Well, that represents how much I've actually gone up or down. And what we have to understand is that I can go up or down here. And so the square root of 16 is 4, or it's negative 4. And both of these answers are sufficient. And so I can have a triangle where negative 4 is the answer. So that would be this one. I've gone down negative 4. Or I could have a triangle where I've gone up 4. And that would kind of look like this. And so that kind of translates to an angle that looks like this for here, or an angle that looks like this. And both of these angles are sufficient. Plus 4 and negative 3. Okay, so then let's get back on track for what I'm being asked for. What is the sine of the angle? So here, and my hypotenuse is 5 in both cases. That has not changed. And so here, the sine of the angle is equal to negative 4 over 5. And here, the sine of the angle is equal to positive 4 over 5. And so both of those angles are sufficient to cosine the angle being negative 3 over 5. Okay, we'll try one more question. So example 3, we're going to solve. Sine of the angle is equal to 1 over 2. Okay, so also have this, that the angle is in between 0 and 360 degrees. So this is like a restriction, and we may have to take that into account. The sine of the angle being equal to 1/2. If we get a question that says solve, we want to know what the angle is. So where is the sine 1/2? And again, this is just kind of memorized that in this coordinate grid, the sine of 30 is going to be equal to 1/2. And so you also check here, sine 30 is equal to 0.5. And so that angle of 30 degrees would have resulted in going up by 1/2, if that makes sense. Hope it does. Okay, so that's that ratio. It's 1/2 to whatever the hypotenuse is. So we'll say that the hypotenuse is 1, and this triangle will make sense. Okay, so sine of 30 is 1/2, but that should also give us, well, what if I went up 1/2 over here? I have no condition on cosine, so this angle should also work. Now that would be 30 degrees up from 180, and so all the way around it would be 150 degrees. And so if I say sine of 150, I should also get 0.5. Same sign, and so that same, it's positive, I should say. They're both positive 1/2, sine 30, sine 150. Even if I inverse sine 150, I will get, or sorry, even if I inverse sine 0.5. I'll get 30. But yeah, I can't inverse sine and get 150. I just, like, that's what's fundamental about drawing all of this, is that there's no way to actually inverse sine and get 150. You kind of have to make that leap conceptually. So, that being said, we have two answers here. There's no other ratio, there's no other angle that's going to give me 1/2. And so we fulfilled from 0 to 360. Down here, like 210 might be a nice answer, but if we enter that, it's going to be negative 0.5. And so that doesn't fulfill this original equation. Okay, so let's move on to the last question. The cosine of the angle is equal to negative 1/2, where sine of the angle is less than 0. So that's telling me that sine of the angle is negative. Cosine of the angle is equal to negative 1/2. So what I can do is go from my reference angles. So cosine of negative 1/2, and also you can use your calculator to help. But if I inverse cosine, I'm going to get 60. And so 60 degrees would be my reference angle, so it'd be up from 180. So I should have 120 degrees here. You can always double check, like cosine of 120 is equal to negative 0.5. So that's kind of where I'm going for here. In fact, I'm pretty sure even if I inverse cosine negative 0.5, I will get 120 degrees. But what I have to also make the jump is I've gone over negative 1/2. I could have gone over negative 1/2 and up, or I could have gone over negative 1/2 and down. So this would be, it's 60 degrees up from 120, or it's 60 degrees down from 180, I should say. And 240 is that answer. So cosine 240 will also be negative 1/2. And so those are kind of my two answers. A common theme here for a lot of the solving trig equations is that there will often be two answers. Sometimes there will only be one, like there will be in this particular question. But if it's just this, it's two answers. Okay, if it's just here, it's two answers. But seeing as I have this, there is now only one answer, because I've given you a restriction on the sine. The sine has to be negative. So whatever this angle is, we also have to look at where is the sine negative. And sine would be positive. The y coordinate, I would have gone up in the y direction. Sine would be positive up here. And so kind of the idea is end this question quickly. These are my two answers, and this one does not apply to sine being negative because it's upwards in the y direction, and you can always check that. Sine 120 is a positive number. Sine 240 is the negative version of that. So I hope that makes sense. That should be everything you need to know for just kind of getting used to working with sine and cosine in the xy plane.